Hi, I am Muskan from Cheenta. Today we will be solving a question from IIT Jam 2018, problem 48. This problem is based on finding probability of intersections of sets and finding whether it belongs to some set or not. So the most important tool in here is Venn diagram, De Morgan's law, and the principle of inclusion and exclusion. You might theoretically know these topics, but we will go very deep into these topics and see how they came into being. We will develop an insight to solve such topics. Let's start the problem. In this question, we are given A1, A2, and A3 be three events such that P of AI is equal to 1 over 3. What is the meaning of this statement? It states that probability of AI, where I can be 1, 2, or 3, that is probability of A1 is equal to probability of A2 is equal to probability of A3, that is equal to 1 over 3. Just for fun, these events are known as equally likely. Now it's given that P of AI intersection AJ is equal to 1 by 6, where I is not equal to j and they lie in the range 1 to 3. Okay, so that means probability of A1 intersection A2 is equal to probability of A2 intersection A3 is equal to probability of A3 intersection A1 is equal to 1 over 6. Further, it is given that probability of A1 intersection A2 intersection A3 is equal to 1 over 6. Now, in this question, let's see the insight of principle of inclusion and exclusion. First, let's define what is that. That says if we have three events, then probability of A1 union A2 union A3 is equal to probability of A1 plus probability of A2 plus probability of A3 minus probability of A1 intersection A2 minus probability of A2 intersection A3 minus probability of A3 intersection A1 plus probability of A1 intersection A2 intersection A3. But where does this formula comes from? Let's draw a Venn diagram. Venn diagram is a powerful tool to solve such questions. It is widely used in set and probability theory. So for that, we'll draw a union set that will include all the events. Let this set represents A1. The second set represents A2. The third set represent A3. A1, A2, and A3. This side that is not lying in the intersection of any of them is just A1, only A1. Let's name this region A. Let's name this region that includes just A2 and only A2 will be B. Similarly, this is only A3 and the region is C. We can further divide this section where there is an intersection of A1 and A2 as D, intersection of A1 and A3 as E, and intersection of A2 and A3 as F. And the intersection of all three of them is given as G. The left hand side is A1 union A2 union A3, that will be given as A plus B plus C plus D, so on to G. Now let's talk about the right hand side, which is given by P of A1 plus P of A2 plus P of A3. P of A1 that is probability of A1 includes small a plus small d plus small g and small e. So A1 can be written as A plus D plus E plus G. A2 can be written as B plus D plus G plus F. And A3 can be written as C plus F plus G plus E. Now, if we add all these, we will get A plus B plus C plus twice of D plus twice of F plus twice of E plus thrice of G. And we want A plus B plus C plus D plus E plus F plus G. So we don't want this extra D, extra E and extra F and twice of extra G. We want to get rid of all of these. And now if we observe that they are actually the intersections of A1 and A2, A2 and A3, A3 and A1. Now if we see carefully, A1 intersection A2 is D plus G intersection, that is D plus G. Then A1 intersection A3 is equal to E plus G, and A2 intersection A3 is equal to F plus G. Now, if we subtract all of them from this equation, what we got using probability of A1 plus probability of A2 plus probability of A3, all of them will be subtracted. 2D will be subtracted. 1D will be subtracted, 1F will be subtracted, 1E will be subtracted, but if we see carefully, all of G will be subtracted. So we want 1G to be left, and that is actually the intersection of all of them. That will be A1 intersection A2 intersection A3. That was the proof of principle of inclusion and exclusion. Let's move on to solve this question. Now, since we have already proved the principle of inclusion and exclusion, let's use it to solve this question. We have to find the probability that none of the event A1, A2 and A3 occurs. So that will be using De Morgan's law. The probability of A complement intersection B complement intersection C complement is actually equal to probability of A union B union C whole complement, and that can be written as 1 minus probability of A union B union, which can be easily found using the principle of inclusion and exclusion. That will be given by probability of A1 plus A2 plus A3, that is 1 by 3 plus 1 by 3 plus 1 by 3, minus probability of A1 intersection A2 minus probability of A2 intersection A3 minus probability of A3 intersection A1, that will be 1 by 6 minus 1 by 6 minus 1 by 6 plus 1 by 6. Now this whole is the probability of A union B union C, and that can be solved, and it will be given by 2 by 3. So our answer is 1 minus 2 over 3, that is equal to 1 over 3. Using De Morgan's law, principle of inclusion and exclusion, we can solve questions like this and maybe advanced question that includes more of this stuff. Thank you.